let's get rolling here. So we got a fun one here today. Thanks for joining, everybody. Welcome to the March Geek Out. So the theme of this month's Geek Out is the Container Boys, and you'll hear a little bit of the backstory here in a moment. We've got some interesting cast of characters here. Not just me. Not that I'm interesting, but got a lot more interesting characters that are also on the show here. We've got Brock Mowry, who is a rock star. I mean, a CTO of Tintri here, and I'll let them introduce themselves here in a moment. You got Sean Myers, who's in the office of the CTO. I think that's correct, right? We've got the voice in the sky. We've got Matt Hebb. I think this is his first official participation in the show.
It sure is.
Yeah, there you go. So thanks. Welcome, Matt. It's great to have you here.
Great to be
And
here.
we also have Mr. Producer, otherwise known as Matt Olson, in the background, making sure everything is running great. So before we get started, a couple of housekeeping items. So we do appreciate you putting all your questions, comments, snarky stuff, comments about the hair, anything you want, location, of course, in the chat. We love that. I typically read out things that are in the chat that I find interesting. So if I ignore you, I apologize. Maybe there's something else going on, I'm not sure, but definitely put things in the chat. As you are probably aware, anybody who attends these webinars live has the opportunity to win one of these. And we are super proud. Oh my, look what it's doing. Oh my gosh, how am I gonna do that? There, we got to put it in front of me because the green screen is also red. That's weird.
Mine's doing the same.
Yeah, so Brock's doing the same thing, but if I put it over here, it disappears. So you will get something that exists. See, it exists there, doesn't exist there. That's weird. So you do get the ability to win one of those. So watch your emails, especially watch your spam folder, because if we tell you you won, you probably want to get that email. So watch that after the show's over. We'll also be telling you when the next Geek Out will be. It'll be in April, so we're going to tease that a little bit now, but we'll talk about that at the end of the show. So with that, why don't we have Brock and Sean introduce themselves before we get going here. Brock?
Yeah, so Brock Mowry, the CTO of the Tintri division. I actually was a former customer, came out of the service provider space, love the product, and I'm extremely excited to show you what we have around Kubernetes today. So thank you.
Thanks, Brock. Sean?
So I'm Sean Myers. I've been here for about 5 years. Field CTO is my official job title, which basically means I like to stand in the field apparently, but we're not going to talk about that today. We're going to have a lot of fun. My problem is my green screen and my hair are not working together today, so I'll have to work on that one later on.
Yeah, the green screen can be a little challenging, especially when it's red.
Yeah.
Right?
I could have gone the blonde wig instead of the other brunette.
Yeah, cool. All right, well, thanks, guys. Matt, you want to introduce yourself real quick?
Sure. I assume you meant this Matt, not the
Yes.
other.
Yes.
I'm Matt Hebb. I'm the graphics guy for Tintri. So, you know, I'm not one of those book smarts kind of guy. But you know, we're front loaded with those guys here. So, and I can't grow a mustache to save my life. So, you know,
You and
that's
me
why
both,
I'm not
brother.
on camera.
Yes. I can appreciate that. If I could spare you all from me being on camera, I would. Unfortunately, kind of the rules of the game. All right. So the reason why we brought Matt Hebb on is because he has the golden pipes. And so as part of the backstory of what we're doing with this Container Boys theme, as you can see with the album cover that he helped create here, hopefully we don't get any copyright strikes on that one. But we brought him in to kind of tell the backstory of what we were trying to do here with Container Boys. So with that, let me flip it over to the next slide and we'll go from there. And oh, you know what? I'm not sharing my screen. That's a problem. There we go. Is that better?
Much better.
Perfect.
Oh, sorry about that. I thought I was sharing my screen. I apologize. Okay. Matt, why don't you help with the backstory here?
All right. Rocking the data highway from VM kids to container kings with Tintri's VMstore. Small town Georgia, 1980. 3 scrappy kids. Bobby Bites, the lead singer guitarist. Stevie Ray Volt, bass and gearhead. And Mikey Megabyte, drums and the voice from the sky, are obsessed with virtual machines on their beat-up Commodore 64s.
So this image was created with an AI tool, and one of the fun things that we wanted to do today is take a screenshot of that if you have the ability to do so. And as we're going along here, see how many things you could point out that are kind of the AI weirdness that we've all grown accustomed to seeing these days, right? There'll be more, but I think this one in particular was kind of funny. So if you can take a screenshot of it, so you can kind of keep it fresh in your mind or on your screen, and then point out some of the funny things that are on there, that'd be kind of a fun thing to do in chat. So with that, there we go. So we're going to get started with the VM Kids era. Matt, take it away.
Small town Georgia, 1980. Three scrappy kids, Bobby Bites, Stevie Ray Volt, and Mikey Megabyte, are obsessed with virtual machines on their beat-up Commodore 64s. They're the VM Kids, a garage band coding by day, jamming by night. Bobby's got the mullet and shades. Stevie's souping up rigs like the General Lee, and Mikey's dropping beats from a treehouse control tower. They're always dodging Sheriff Mainframe, a strict sysadmin trying to shut down their unauthorized VM experiments. They use early machine learning to balance VM performance. Think of it as tuning their amps for perfect sound. One night, they hotwire a VM cluster to run a virtual drag race, outrunning Sheriff Mainframe's kill switch with a rebel yell, "Ain't no one containing us yet."
Yes. And I love hot wiring cars. That's kind of my, oh, am I supposed to say that? Oh, my bad. I'm anything that's been happening recently, the sheriff's department's probably going to pay me a visit here pretty quickly. But anyway, so with that backstory in mind, it's kind of the first era of the evolution of the VM store. So what I want to do just briefly is kind of set a level and show you kind of what that first era looked like. And for those of you who have seen the brief history of time geek out that we did a while back, that'll give you some more background about how this all came into being. But for those who might be new to the VM store technology, what I thought I would do is throw up a kind of a view of what we do at a foundational level. So kind of this early era, if you will, and some of the basics. So I'll do this real quick, but basically what a VM store does is it allows you to visualize what workloads are doing from a variety of different angles. So one of the first things that we do is we connect to whatever workload manager you're using, and that can be a hypervisor management plane like vCenter. It can be other things, as you'll see. I don't want to spoil it, but there'll be other things here in a moment. But one of the most basic things that we did from the very beginning is connect to, for example, vCenter. So what we're doing is we're then pulling inventory from vCenter, and then as workloads start to load onto our devices, we then map those workloads so that you can also do things like reporting on individual workloads, like VMs, for example, and be able to see what they're doing individually. So as you can see here, this is the overall view of what we do from an overall array perspective. So we've got latency metrics here, telemetry. We've got space telemetry, all the basics that you know and love if you're familiar with our product. But we go a lot further than that, actually. So we can do things like view things at the virtual machine level. I'll use workloads also because we're going to be expanding that as the eras progress. But in terms of how we got started, this was really started with virtual machines. So if you've got a bunch of VMs that are running in VMware, for example, you can see what those VMs are and what they're doing individually, right? So you can go right down to, are they busy? Are they experiencing high latency? All the different things that you would want to know about your individual workloads. We're able to do that. Now, obviously, there's a lot more to it than just that. But I think this is a good flavor of kind of how we got started, what the building blocks are, or the foundational technologies that we use to build for some of these additional eras and additional workload types that we're brought into the fold. Okay, so with that, let me go back to my slides here real quick. And there we go. Okay, so with that, now that we've covered some of the basic foundational stuff real quick, what I want to do now is kick it over to Sean, otherwise known as the rocker in waiting here, and we'll get him to share his screen and go into the second era, known as the SQL Teens era.
So obviously the timelines are way off here from a date perspective, but that's just to add to the fun.
We're just trying to have fun with this, right?
Absolutely.
So Sean, why don't you go ahead and share your screen, and then we'll have Matt do the readout from there. There we go. Perfect. All right, Matt.
All right, we're now into the SQL Teens era. Mid-'80s, the boys are teens, cruising in a souped-up Chevy Camaro, the Data Duke. Their gigs now include managing SQL databases for local businesses. Structured data is their new jam. They trade floppy disks like mixed tapes, rocking out to Van Halen while tuning SQL queries. Stevie's wielding a database rigs with neon lights. Bobby's belting lyrics about data freedom. And Mikey's hyping the crowd with a makeshift DJ booth. They're running from Boss Disk, a corporate suit who wants their tech locked down. They invent snapshot jumps, backups to dodge data crashes like the General Lee leaping a creek. During a midnight SQL jam session, they save a warehouse's inventory from a power outage, cementing their rep as the coolest data outlaws in town.
Yeah, so what we want to talk about is basically SQL integrated storage. That is, we want you to expect and get more from your database storage. So as the container boys were hanging out together, going, hey, so what actually is a VM? Basically, a VM is just a collection of files. There's metadata with that, and it basically resides in your storage. And we manage those files by a hypervisor. Tintri created in our last era the Tintri basically VM aware storage or VM integrated storage, and we're definitely a recognized leader for that. So we're sitting there thinking, going, "Hey, dude, what's possible?" And you know what? What's a database? Database is just a collection of files. It's with the metadata managed by a database management system. Huh? Sounds familiar, doesn't it? So we decided to go, "Hey, can we do the same thing per database as we did per VM?" And the answer is yes, absolutely. We created a thing called Tintri, basically integrated storage, which is basically also DB aware or DB integrated storage. Lots of different names for it. It revolutionizes how you look at and manage SQL Server database systems. What we did before, the first time, basically in the old days, we used to have a LUN, legacy storage, and I've got multiple VMs on it, and then I have different IO patterns, different problems, and everything's all one giant bucket, and I had a hard time managing it all. With the VMstore, we took the VM out and made it into an individual VM, and we can manage it at that layer, which is fantastic. But with databases, we find out, hey, look, normally there's about 7 to 10 different databases per SQL Server instance. And each one of those has a different IO pattern as well. Well, what if we can manage them individually, kind of stuff? And so what we did now is we took that individual database here, and we're going to pull that out and make it run on an individual database level kind of process. And that allows us to actually do some really cool things. So we're going to do a really short demo just showing what we could have done with things or what we've done with this process. So we're going to go to SQL Server. Yeah, big screen here. Over in a SQL Server real quick. Where my toolbar? There it goes. All right. So we're going to go play the database here. Right click, properties. If we look in this thing here, we see this database is right around 358 gig in size. That's a fairly large database kind of process. But of course, I have my production server and I have my development server. And my development server, I have some copies of the same databases. Ooh, wow, is this crawling today? It must be a demo gremlins coming in to get me.
Demo gremlins, yes. Very familiar participants in the show.
Yes. So I don't do anything else in this lab right now. But while we're waiting for it to refresh, we're going to go switch screens off to the TGC or Tintri Global Center. I'm going to show you. In here, we've got a databases tab and listen to all my databases. This lab only got a couple databases processes, but you can see that database we're looking at, even though it's 358 gig in real life, in here, actual size is right around 78 gigs. So basically, this is how much space it uses on disk. Dedupe and compression do some amazing things with SQL servers. So we're going to make a copy because what it is, hey, we've got a problem with production, but the developers need to go take a look at it. I don't want to have them poking around my production system because that's always a bad idea. So we're going to make a copy of this database to allow the developer to go take it apart in a known state where we're at. So we're just going to go into here, right click and clone. Let's go back to SQL, see if it's loaded up here on the dev server. All right. So you can see I'm doing some testing with some corruption issues. So I've got these broken databases here, but this is the list of the databases on my dev server to allow my developers to go play with. I don't want them touching my production servers.
I like the one called Stash.
Exactly. Well, that was my walkthrough of the
it's very appropriate
here, just to make sure it's going to work properly.
By the way, for those of you watching, the Stash is not a prop. The Stash is real. which is mind-blowing to me.
Seriously? Yeah, I can
Oh,
talk
I
about
love
that
it.
with Conkai voice.
It's an amazing mustache. Yes.
So the first thing I
Sorry.
want to do is make sure I put a proper name to it. So I use clone in the names because I have a script that deletes my clone databases basically every week, so I can get rid of stuff and keep my environment clean. Geek, I should probably call it Geek Out Clone, not Geek. All right, snapshot. I'm doing hourly snapshots. I can pick one of those, or I can do a brand new snapshot. In this case, I'm going to do a brand new snapshot because I want a known good current state. Which server I want to put it on. So I want to put this on my dev server. And then, of course, where I'm going to store the file. I'm going to store it in my dev studio folder. And click clone. Basically, I start humming the theme song to Jeopardy. Oh, wait, I didn't get that far. It finished before I even got there. Back to SQL Server. I can go right-click and hit refresh. Hopefully, it's not going to take this long to spin out. Most likely, it's going to. But it's going to show up basically eventually because apparently something's wrong with this SQL Server right now. It's not very happy, even though I can still make refreshes and copies to it because now you can see, there it goes. It shows up. The clone process is there. I go to SQL Server. Still not quite done, but it's going to show up their process. But the other day is I made a full working copy of a nearly 400 gigabyte database. So now without impacting production and allowing the developers to go work in their own isolated environment. And you saw I did it in a couple seconds. And that's the cool thing about SQL integrated storage. All right, Brock, over to you.
All right, if you could drop your share for a second.
Let's go to the next era.
To the next era. Heb, you're up.
Did we finally get to the container boys? Are we there? We're there.
Oh,
the
we've
container
come of
boys
age.
come of age.
That's right.
Yes.
Late 80s, the boys are full-on rockers, rolling into gigs in a monster truck dubbed Containotron. Containers are the new frontier. Lightweight, fast, and whoops.
Oh, sorry.
Lightweight, fast, and perfect for their wild lifestyle. Bobby's shredding solos about persistent volumes. Stevie's electrifying the stage with container rigs, and Mikey's emceeing from a spotlight tower. Ladies and gents, the Container Boys are live. They're the Dukes of Data, living fast and free. They're chased by Deputy Docker, a rival crew, but outsmart them with lightning-fast cloning, spinning up container fleets like Bo and Luke dodging Roscoe. Their VMstore hookup with Tintri is their Daisy Duke moment. Hello, Tintri, we're home. At a rock festival, they deploy a Kubernetes cluster mid-set, delivering high-performance persistent volumes with QoS, snapshots, and cloning, proving that they've gone from VM kids to container kings.
I love the Roscoe P. Coltrane reference. That's solid for those of us who are kids of the 80s.
Yep. So I'm going to go through a quick walkthrough of the new VMstore data services for Kubernetes, as well as our CSI driver. So I got a couple of slides here I want to run through, but try not to kill you guys with slides and jump into the demo here real quick. So why are we going down this path? Why the VMstore and Kubernetes? Well, what Sean clearly illustrated in his little demonstration was, at the end of the day, a lot of these systems are just based off of files and a manager. You've got SQL as the manager, you've got files for the database, you've got vCenter for the hypervisor, you've got the data store with the VMDKs as the files. Not much different in Kubernetes land. So we are working with Kubernetes. We have created a CSI and data service that allows our users to easily deploy and consume persistent volumes within a data center space. We've also added some things within our UI to help make the transition or the uptake of Kubernetes a lot more easy for our customers that may not be from a Kubernetes background. So we've put things in place to allow fine visibility or observability on the VMstore side that you would also see within the Kubernetes cluster. So we wanted to simplify the adoption and make things as simple as possible, like we do on the virtualization side and the database side, to be able to get high performance, persistent volume based applications up quick and simple. So this is our 1.0 release of a CSI. So this is our initial integration. So what we have here are some pretty basic features, but they're extremely powerful when they're coupled with the VM store. So we do have the ability to dynamically provision and manage persistent volumes within a containerized environment, as well as the detachment and cleanup. That's obviously very important. But that then enables us to be able to work with cloud native orchestration platforms and different cloud native applications. So you may have seen this slide before in previous contents. We off to the left-hand side have our traditional IO blender. This is what we see in legacy storage architecture, where all of the workload is fighting for the same attention to get in and out of the system to feed the application. On the right-hand side, this is how we approach it. It's a little bit different. So each virtual machine's vDisk, each SQL database, each Kubernetes persistent volume gets their own IO lane when it's created. There's a discovery process that happens. Once it's then picked up, then we create all of those VMstore features around those individual workload objects. So it gives us visibility all the way down to the individual disk or volume or database. So I'm going to show you a couple screenshots here, but we're actually going to get into a live environment. We've got two different ways you can manage the Kubernetes environment from your VMstore infrastructure. The top is through Tintri Global Center. So Tintri Global Center is our overarching control plane. You can manage up to 64 individual VM stores under that single pane of glass. So from here, you see the Kubernetes drop-down menu. You can pick clusters, you can pick deployments, pods, containers, persistent volumes. And what that's going to show you is not just a single instance of a Kubernetes cluster, but it's going to show you what's deployed within your entire fleet of VM stores. Versus down at the bottom, we're looking at a single VM store. So you can see there's a difference. It's not a drop-down menu, it's a set of tabs. So we've got cluster deployments, the same thing you're seeing in the drop-downs, but it's specific to the individual VM store that we're logged into. Some other areas, we're able to manage multiple Kubernetes clusters. So screenshot in the back there is representing at least 4 clusters attached there. Then all of the containers within the entire fleet, the persistent volume claims and the persistent volumes. Looks like these screenshots got chewed up a little bit here, but you can notice off to the right-hand side, those are blue hyperlinks, which allow you to drill into the individual detail of the persistent volume. Again, we'll see this live, so you'll get a clear shot of the UI. Again, ease of use. We've heard a lot of challenges from our customers that are new to the Kubernetes environment. An example: everything in Kubernetes is done from the command line. So you can see here, there's kubectl get pv-all in the left-hand side. Let's pull in an inventory of all the persistent volumes that we have in our environment. It's kind of difficult to sift through and find the one that you're looking for. It's a lot of information at your hands. Versus on the bottom right, we've got the VMstore UI for managed objects. Now you can filter down to the object type to see just CSI. Then you can take it a step further and filter by the file name as an example. And then you still have a ton of rich information around the performance of that persistent volume. So you can see IOPS throughput, our wonderful latency box there to be able to identify where latency is being derived from, as well as some capacity information further off to the right. So deeper visibility into persistent volumes. So this is actually selecting one of the individual persistent volumes. You can see, we can see IOPS, throughput, latency, again in this screen, but there's also breakout screens like the persistent volume metrics where you can see real-time performance, whether it be IOPS, latency, throughput, so forth. There's a whole collection of stats that you can pull from those drop-down menus. And then the last screen on there is the persistent volume snapshots. So we can take snapshots of our persistent volumes, do different activities like cloning off of them, and be able to provide a really good infrastructure to manage Kubernetes storage. So one of the things that the VMstore has always prided itself on is simplifying the deployment. So a lot of the other vendors out there with persistent volume capabilities, it's a very difficult deployment. It's very involved. There's a lot going on. We tried to distill this down to be as simple as possible. And I think we've got it down to, I believe it's 6 steps. So First step is configure your VMstore for the Kubernetes service. Obviously, you want to make sure that you have the prerequisites off to the right there. So 1.14 on Kubernetes or greater, and then the VMstore running 5601 or greater. Once that's done, download the files from our GitHub. Matt, if you could post that GitHub link in the chat for others to grab, that CSI driver is up and available for downloads. Then the next thing is with that download, there is a config file that you need to generate a Kubernetes secret for the CSI driver. Then you push the driver installation. So that's that VMstore CSI file driver YAML. And once that is completed, you install the CSI snapshot driver CRD. This now gives you the ability to take snapshots of those volumes, and then you deploy the controller, which is the component inside of the Kubernetes cluster that manages all of the snapshots and the communication between Kubernetes and VMstore as it relates to snapshots. All right, so that is enough of slideware. Let's go ahead and jump in here. I'm going to pull up a demo, and we're going to take a look through the environment. So let me go ahead and get logged in here. And from here, you can see we have a VMstore. It's a T7000 in one of our labs. We're running 5.6. You can see down here on the bottom. And we also have the Kubernetes services installed and configured. So I want to show you where the details are for this. So under Hypervisor Managers, we do have a tab here for Kubernetes cluster. Now, I want to remind everybody, we do support more than one type of Kubernetes cluster. We also do support VMware's Kubernetes distribution Tanzu or TKG. You can add additional Kubernetes clusters from here. So if this is a Tanzu Kubernetes environment, you check this checkbox. This will do some more deeper investigation of the VMware side of Tanzu. Add in your API endpoint, your cluster name, paste in your certificates, and then you have a test button here to make sure that everything's correct. We've already got one set up over here, so I'm going to go ahead and grab this guy real quick and show you a configured one. Go ahead and click test. We can see it's successful. So we are good to go. So another key area is this volume file settings. This happens, this section enables the data services for Kubernetes as well as the discovery of new workloads and new objects. You do need to come in here and check off the enable box. We do have the ability to change the subdirectory that the CSI storage is being directed at. So in this example, it's /Tintri/CSI. And then once this is configured, you are ready to go. So I'll jump over here to the Kubernetes tab. You can see we do have an active cluster, but you can see across the tabs, there's not much going on. As a matter of fact, there's nothing going on. So what we're going to do is we're going to change that. First thing, when you get over to your Kubernetes cluster, you go ahead and stop some of these. I got a couple of these commands here, just keeping my sessions alive. All right, and one of the first things I want to do is I want to go through the details of the components, the VMstore components that are inside the Kubernetes cluster. So I've created a little script here that just does the commands, keeps me on track here. It doesn't, I don't have to fumble around with typing. So first thing we're going to do is we want to check to see if that secret is present in this cluster. As you remember, I said that we needed to create a secret out of a config file. That is the usernames, passwords, the endpoint for the management of the VMstore, as well as the Kubernetes cluster detail. So we do see that we have a config here. It is opaque, so that is encrypted. We are able to use that or leverage that within our deployments. So next thing I want to do is I want to see if we have the controllers out there. So I'm going to get pods and I'm going to look for anything that has VMstore on it. So you can see each node has a CSI node on it. These are effectively the workers that go out, attach volumes, do all the fun stuff. And then we have the CSI controller up top, which manages all of the nodes. So we've got a good environment here. We know everything is available. So let's go ahead and check to make sure we have a storage class. We can see we have a VMstore CSI file driver storage class. It has a reclaim policy of delete, and it's tied back to the VMstore CSI .tintri.com provisioner. We're going to pull some persistent volumes and persistent volume claims, which is going to return nothing because we haven't deployed anything. We're going to do the same thing to look at the snapshot controller. So we can see we have an active snapshot controller within the cluster. And then we're going to get volume snapshots class to see if the snapshotting is configured. It is. Again, you can see the driver is tied back to that VMstore CSI Tintri.com driver. And let's list any snapshots. There shouldn't be any here, so we haven't done anything. And that's the end of the view of all of the VMstore assets within a Kubernetes environment. So I'm going to switch gears here, and we're going to do a web server demo. So the way that this demo works is we're going to deploy a persistent volume. I'm going to push an index.html file into that persistent volume. We're going to have Nginx running over top of that, so we'll be presented with a web page. We're then going to clone that persistent volume. Well, take a snapshot and clone from the snapshot and deploy the same web server with the same persistent volume, just under a different name from cloned data. So without further ado, let me go ahead and get started here. So this screen in the middle here, by the way, is a kubectl get command. It is going to pull up pods, services, persistent volumes, and volume snapshots for anything that has ngin in the name. So as I'm creating these assets, you will see them pop up, excuse me, pop up in the center screen. And I will have to pull some information from them as I go through. So it's just kind of a heads up dashboard there, if you will.
So by the way, if there's any questions, just throw them in the chat. The feedback that I'm getting from the chat is that you need to do this in the voice of Roscoe P. Coltrane.
Oh man,
that seems to be a very popular topic.
I can't. If I had a voice changer, I'd be all for it. But sorry, can't do it.
Maybe Sean can try. I'm not sure.
Yeah, we'll do a post-production before we post it up. How about that?
Okay.
All right, so I'm going to run a very similar script. I've just added the commands. Again, I'm not hiding anything up my sleeves. It's just so I don't have to type these commands over and over and fumble around in front of you guys. So welcome to the VMstore CSI demo. So the first thing we're going to do is we are going to deploy that Nginx persistent volume. And we see it pop up there in the center screen. We also see it in a bound state. What that tells me that it's available for my next step, which is good. Now we're going to deploy that Nginx container over top of it. And we saw that pop up right here. And I'm actually going to snag this for a second for a future step. And got it. So now we're going to deploy a service. Now I'm not using cluster networking in this cluster. I didn't have enough time to get it properly straightened out. So the demo is going to be off of node port. So I do need to grab an IP address and a node port in order to pull up the web page. So we can see here, we now have a service for Nginx that is running on port 310.95. So that is available and there. So let's go ahead and just pull some quick info. So what I want to do is I want to actually push a website, web page into that web server. So I have a quick command up here. Oh, it's like I highlighted that and stole my copy. There we go. So I'm going to do a kubectl cp, which is a copy command. I'm going to move that index.html file into the web server so that we have something to look at. So let's go ahead and do that. Boom, we've got that in there. Now we should be able to go into, this is on cluster 2, worker 1. I have, one second. Created a snapshot of that volume real quick. Sorry, let me do that real quick. And then here, now I can get my services. So I've got this IP address that it's hosted on. Go ahead and grab a private window so we don't have to deal with any caching issues. I'm going to go back and grab that port number again real quick. If all goes well, we should be presented with a web server. Hey, container boys, look at that. So we've got our own website now. So what do we have in place? We have a web server that is supported by a persistent volume that holds the index.html file for the web server. So this is a persistent volume backed website, and it was brought to you by VMstore's persistent volumes. So
with a Nintendo font, which I just
with
love.
with the Nintendo font. So AI generated website. I will fully admit I did not create this HTML or the slick CSS that I asked for in the prompt. So I was personally impressed. So I was quite happy. It's a low effort website. All right, so now let's take it a step further. Let's say that we have a scenario where we need to do some maintenance to this website. We need a snapshot and a clone of this web server so our developers can come in and do work on it. Well, you can see we are on .175 from a host perspective, and that port number is really important because when I schedule the next web server, it could show up on the same node and have the same IP address, but it will have a unique port number. So let's see how Kubernetes schedules this job for us. So I'm going to jump back over to my script. What you can see here is I have ran a couple of commands. So I did take the volume snapshot class is listed as unchanged. I already have that. That's basically the parameters of our snapshotting. I then took a snapshot of the Nginx demo persistent volume. So if we come up here, we can actually see we have a volume snapshot of the Nginx demo. And then my next step is I'm going to take that snapshot and I'm going to clone it to a new persistent volume. So when I hit this entry here, we should see another persistent volume appear in the center screen. Everything goes well, boom, it's in a pending state. Just went to a bound, so we are good. You can see this is now called Nginx clone PVC. Then let's then send out the cloned deployment. So we'll see another deployment like this one up here come out. Boom, we see the new deployment listed as clone. See it's in a creating state, it's up and running. It did in fact get scheduled to the same node in the cluster. So now let's create a service of which it will be a unique service port, unlike this 310.95. So let's create that. All right, popped out. So now you can see we've got a 30408, and that web server should be up and operational. So let's go ahead and check it out. So I'm going to grab this IP address again, and we're going to pull up a new tab here. And again, unique port number. So it is this one here. Port number, enter. Hey, we got another cloned website. So now you can take this exact duplicate of this production website. You can go and modify it to your heart's content. So what did we demonstrate here? The VMstore's ability to provide persistent volumes, the ability to snap and clone those volumes, and then deploy a fresh site over that same data set. And one of the other things I want to do is I want to jump back into the VMstore. I've been doing some stuff on the other side, so I do want to kick off a manual refresh here real quick. And while that's refreshing, I wanted to see, is there any questions in the chat or any questions from the panel?
No questions in the chat. I did get some good reactions to even suggesting you do it as Roscoe P. Coltrane. Understand? Maybe Matt Hebb can do that professionally. One question from a familiar face, Lou. Where did you get the hair?
It's Amazon special. It was Prime delivery.
It's not AI generated?
No, this is all real, baby. All right.
Yeah, you're
so
getting some good feedback about the hair for sure.
That's great. So another thing to do, let's kind of walk through the VMstore UI as well. You can see this VMstore is in our lab environment. We got a lot of crazy things going on in here, but I wanted to show you, we saw screenshots before, how simple it is to kind of get down to the meat and potatoes that you need to work on. So we want to see everything. Oh, I don't know what happened here. Looks like I lost my VMstore UI.
Oh, your session's time out after X time, and you probably had it open too long.
Yeah, it's too much yakking, not enough.
Yeah, while that's refreshing, we did have another question. Where can this capability fit into CI/CD workflows and data analysis?
Yeah, so this could tie directly into CI/CD for sure. Cloning operations are very common within CI/CD. So you may have a persistent volume as an example with a static data set that needs to be deployed to multiple containerized applications. You can easily write a routine using our cloning capability to rapidly deploy all of those duplicate sets of data. And like Sean showed, it's technically not duplicated. It's not duplicated on the file system level. So you're only going to see the difference in delta space between the original and the actual duplicated copy. So very space efficient.
So the bigger the bigger the data sets are, the higher value it can be.
Absolutely, absolutely. So let's try this again. We're going to get into the CSI. So perfect, filtered down to the two persistent volumes that we have in this environment. I'm going to go ahead and jump over to the Kubernetes tab because I think there might be some more interesting stuff over here. There absolutely is. So we can see our production Nginx deployment. We can see our cloned Nginx deployment. We can see that they are operational and running. Everything looks happy, available, progressing, great. We look at the individual pods. So we can see we've got these two Nginx pods that represent these applications. What containers? They're both running an Nginx container image. Their image is from the Docker IO library. And then we can see our persistent volume claims as well as our persistent volumes. And like I mentioned before, that sorry for the bad screenshot earlier, but we see it here live. We can actually click on this persistent volume and it will take us straight, goes back to the manage objects, but takes us straight to that individual object. I deployed web servers, not a ton of activity here, so apologize, there's no active data here, but if there were, we could see IOPS. Actually, I might have it off the other one because I did do a clone operation. Now, sometimes when I do a clone, I'll see an IOP pop up here, like 1 or 3 or whatever. But you can see some very good detail around the performance of this persistent volume. So another great use case, you're using something like a MySQL instance or a database engine within Kubernetes, and you need to see how the underlying storage is performing. So the persistent volumes that are supporting the database app. We can give you that visibility at the persistent volume level. That's something that I haven't seen come from our competitors yet. You can also see on here, this one doesn't have the snapshot. It's actually this one. So we can see this is the snapshot that we took during our workflow. You can see it was a user-generated snapshot, pretty small in size, but we can take actions on these snapshots now that they're present like we showed before. And then under the metric screen, again, a ton of information. There's not a lot of I/O on this system right now, so these charts aren't pre-populated or populate out. If I was running something like a database or a load test, there would have been static data here already waiting for us. You can compare between different persistent volumes from a performance perspective, as an example. So if you have 2 apps that are doing something similar, but you're seeing a performance discrepancy on one, you can compare the 2 side by side. And then I mentioned before, we have a whole litany of metrics that you can look at for systems that are managed by a VMstore. So get a very good idea of performance and capacity and all aspects of this persistent volume. All right, that is the tech jam.
So I think we have some poll questions. I don't know if we want to throw those up now.
Yeah, let's
while
go
we're
ahead and
waiting
do
for
that.
additional questions to come up. Yeah, I think that'd be a good time. So Mr. Producer, why don't you throw those poll questions up if you don't mind? And again, any questions that you all have out there, let us know.
And real quick,
Not about the hair anymore. We're not talking about hair anymore. So
here is the GitHub, Tintri's GitHub with the VMstore CSI driver. So just to walk through this a little bit so everybody's familiar with it, very detailed README. It's very, very simple deployment. Some of the feedback that I'm getting from my field conversations is this is extremely simple compared to everything else that they've been evaluating. So we're happy to hear that feedback. You can see in here too, there's a bunch of examples. So we do put different types of examples of what you can do with the CSI beyond even things that I showed you here. You can do some pretty interesting things with topology architectures. Yeah, there's a ton of stuff in here. So we also, within the download, there is the deployment files that I discussed before. So this is the file that you need to create a secret out of. This driver file is the actual driver that you would deploy. And then we also have a collection of examples here. So creating Nginx dynamic volumes from a persistent snapshot. So some of these are similar to the workflow that you saw, but these are good starting points for you to come in and grab details and work them into your either your CI/CD workflow or just your day-to-day type of workflows.
Nice. So poll questions are out in the chat, everybody. So one of the ones that's particularly interesting to us, well, actually two, is, where are you in the journey? It seems like the feedback so far is people are just getting started with this, which is not uncommon. But if you are starting out with it, we're kind of curious about which distributions you're using for Kubernetes. That helps us drive some of our development activity going forward and make sure we're supporting what you guys are using out there. I think we have a pretty good idea of what the market's doing. But if there are specific things that you guys are doing, we'd like to make sure that they're under consideration. So throw them out there. If you're using anything unusual, or even if you're not, even if you're using something fairly standard, we'd like to know what that is. So make sure you put that in the chat. So everybody, so the responses so far are evaluating, very beginning, POC stage. Again, this is not uncommon. So throw those answers in the chat there.
And another thing I can do over here too, just to show I don't have any cards up my sleeve, is we have been working on a live Kubernetes cluster.
Yes, this is not a totally canned demo. So
yeah, so you can see
some stuff.
Some stuff. We can see our Nginx deployments in here. We can see our snapshot controller, our VMstore controllers. So I built everything in a script to keep me on track more than anything, and not have you guys watch me murder the command line.
Keyboards are greatly appreciative. Yes.
Yes.
So any more comments? I think those are the only ones we have so far. No other questions from the audience? Love to answer them if we can.
Yeah, I'd also add anybody that is starting the Kubernetes journey. It looks like we've got a couple of entries in there in the chat. Please, I'm happy to get on a call and discuss, my knowledge, my skills, my experiences with you as you're starting this out. Hopefully that can help you get a leg up on getting a successful deployment out and in place. We're doing some really cool things with the VMstore. This is just the beginning. We've got a whole roadmap of features that we're going to be releasing on the CSI and the data service to just ultimately enhance the end user's experience.
So for those who don't know, can you expound a little about what the difference between EKS and AKS is?
So EKS and AKS, those are both cloud service providers Kubernetes offering. So I think it's AKS is Azure Kubernetes Service, and EKS is
it's Amazon's Elastic, isn't it?
Yeah, I think it's Elastic Kubernetes Service.
Yeah.
Yeah. Sorry, I'm not up on my my acronyms. I need to study a little bit more.
Well, that in fact we focus on prem, and for those who are running into basically your cloud spends getting outrageous, that's when this stuff comes really handy. You can scale as you need to with the VMstore, and we support feature sets very similar to what you're going to see up there.
Yeah, and there are some on-prem offerings from those cloud providers. So I know Google's got one, for example. We are looking at supporting the CSI driver in those arenas as well. So look out for support statements coming around those on-prem cloud provider platforms.
Nice. All right. So I don't see any other questions at this point. So Brock, we lost your hair for a moment.
Yeah, sorry. I'm moving windows around. I shut my video off.
Cool. All right. So no other questions. I'm stalling as long as I can, guys. Come on, get those questions in.
Well, so Steve, let's go back. What other things from the opening AI picture did we find wrong?
So most people were focusing on the text, which was wrong. So does somebody have that slide we can put back up there?
I should. Jump over to my other screen.
Yeah, there was some pretty egregious stuff in that picture. Oh, this is the weird one. Yeah.
Yeah, this is the
So,
bonus picture. I sent this
Yeah.
out to the crew last night. So
oh,
this one's
jeez.
rich of strange things.
Yeah. So I
I love the
don't really
drummer.
understand the drummer like at all. Like that, like somebody said last night, it looks like Plastic Man is playing the drums. It's really kind of hilarious.
Yeah, his
Um,
arm's all the way over here.
and did somebody notice that one of them has two left hands? Did I hear somebody say that? Um, it
Yeah,
looks
that
like
looks.
his left hand has a thumb in the wrong place. So that was kind of interesting. Yeah. But going back to the original one, some of the signs had some very interesting spellings on them, like containers with two T's, um, VMstore or something or other on the left. I'm not sure what's up with that. Um,
Story.
yeah, maybe it's Italian for VMstore. I'm not sure, but
I think there's some extra fingers here.
yeah, I think there are some extra figures. Yes.
I don't know what's going on here.
Yeah, the guitar is floating on his hand.
Yeah, that's a little strange. Yeah, he does have a strap though, so maybe it's attached to the strap. But it looks like the strap. I don't know if it attaches to the other side. That's the other thing you can't really see. But yeah,
And of course, today is
very
Mac
interesting.
26.
Yeah, Mac 26. I like that one too. Yes.
Yeah.
Yes. So anyway, so yeah, so most of the folks pointed out the text problems. So, but the hands are frankly a little creepy, but that's pretty common with these AI pictures now. So
So I wanted to give an update to the container boys. As you can see, Sean and I are still very active in the music scene. We get out, we do our things, but Steve unfortunately had to go corporate. He had to get a job. He had to stop with the band. He had to cut his hair. We miss you, Steve. We need you back on the band. We're missing our drummer.
you don't want to see me with long hair, trust
Or
me.
sorry, you are a bassist. See
Yeah.
how
Yeah,
well
yeah. So Laura pointed out, I think this is really good. This is very observant. So Laura pointed out that the guitar looks like a four-string bass at the fretboard at the top, but then it
Yep.
turns into a six-string guitar, at the bottom.
And I think I
That's
only
really
see
observant.
there's four machine heads on the head of the guitar too. That's where the you tighten the guitar strings at the
Yeah,
top.
Yeah.
yeah. So that you get bonus points for that. That's very observant.
Detailed.
Exactly, exactly.
And I think the keyboardist looks like Andre the Giant's little brother.
He kind of does, yeah. I kind of thought he looked like Neil Schon from back in the day, but Neil Schon was a guitarist and a keyboard player. That was Jonathan Cain. Um,
Hey, Steve,
but it's kind of a
we do
weird
have a
amalgamation
question
of them.
under
What's that?
Q&A.
Oh, we had a question in Q&A. Oh, sorry, I missed that one. So what performance characteristics can be expected from persistent volumes?
That's worded kind of strangely to me. So what performance
So
characteristics?
are they the same? Should you expect the same performance you would get with a VM or a SQL database, for example?
Yeah, I mean, ultimately, we're looking for a low latency experience. That's one of the reasons why our product highlights latency so much in so many different areas. So definitely a low latency, high throughput architecture. So it's going to follow along the same lines as the virtual machines performance and the database performance. So the busier you make our boxes, the better outcome and experience that we ultimately see. So definitely. We want to see details around latency expectations from customers, especially in database environments. So if you guys have any of that out there and you could feed with me, that would be awesome.
And the other thing too is, the quality of service that we offer on our objects basically is you're definitely going to be per persistent volume as well.
Yep.
So you no longer have to worry
Right.
about noisy neighbors or impacts of other workloads on your workload. Whether
Yeah,
it
and that
be
goes
the
back to the core foundations we talked at the very beginning, right? So that stuff was all built in at the very beginning, and now we're just extending it to different types of workloads, which I think is a huge value prop.
Right, it was a perfect fit.
Yeah. And that's the fantastic thing is, I mean, you can run your databases, your VDIs, your VMs, your containers, all on one storage platform natively and get the insight for each the same way. So you can analyze your workloads as you need to.
I see a comment from Phil. Answer the question I asked. Someone
Yeah, that was the
re-answered it.
one about CI/CD workflows and data analysis. So we talked about that one
Yeah,
earlier.
Yeah, we answered it, but I'll definitely double back on it. So there's definitely some interesting capabilities with our snapshot and cloning around managing large data sets. So I kind of mentioned that before, but where we're starting to tiptoe in and look at is as an example in the AI workspace. We see customers that are deploying AI apps over top of us. They get a data set ready for inference operations, and they find, okay, we need this data set in more than one place. So just a single instance of that data set is not going to fit. Or you've got a team of people that are developing against that data set and they need to take their own unique copies. That's an awesome use case for the VM store. So that's where we can clone different data sets out to those individual users while still preserving the original one. All of our snapshot rules that you see about VMstore snapshots all still apply here. They're not time-based, so you can restore them multiple times and you won't end up with your latest copy if that's the one that you restore. We have a lot of flexibility within the data management side. So if you've got these big data sets and you've got a third-party application that maybe you need to run them through, you can simply dump a copy through a clone out and it'll have zero impact on your overall capacity as well as the performance of the box. Another use case I tout quite a bit on the virtualization side is around security. If you've got a big web app with a bunch of persistent volumes and you have a auditing team or a penetration testing team that needs to come in and do some disruptive testing on it, we've seen this use case on virtualization over and over again. Clone the environment to a duplicate set of virtual machines, wall that off from a network perspective, and let the pen tester go in there and go wild. It's not going to impact your production. They have their own private environment with their own data that is an exact duplicate of the production data. So some really good use cases there.
It's a great point. Okay, look at any other questions that we didn't get to. I don't think so. So thanks, guys, for coming by, and we will see you next month, April 23rd. See you then.
Thank you.